Good morning, students. Today we are going to learn about the periodic properties. So the periodic properties exactly means the properties of the elements which are directly or indirectly related to the electronic configuration, and they show a different gradation as we move across the table, like a periodic table from left to right, or we are moving it down to the group. So we have six important periodic properties, and one by one we will learn about each and every periodic property. So now let's see. First of all, we will talk about the atomic size. Okay, so atomic size is also known as atomic radius. So this can be clearly understood with the help of a diagram. Like we have a structure like this. Now the distance from the center of the nucleus of an atom to the outermost shell is known as the atomic radius. So atomic radius can be defined as the distance between the center of the nucleus of an atom to its outermost shell. If we have one more outermost shell, then the distance will increase. So we can say that it depends, the atomic size depends on number of shells, because as the number of shells will increase, the distance from the nucleus will increase and the radius will increase. Now we will talk about one more term in this, which is known as a nuclear charge. So first of all, let's understand what is a nuclear charge. So the nuclear charge means the positive charge present in the nucleus of an atom, which is equals to number of protons in the nucleus, that is, which is equals to atomic number. We will see that when the nuclear charge increases, it means there is decrease in size of an atom. For example, we have a sodium. The electronic configuration of sodium is 281. When it loses one electron, it forms Na plus. It means one charge is there, so its electronic configuration will be 2A. So now you can see that if I'll draw the structure for this one, this is a nucleus, first shell, second shell, and the third shell. Means we have three shells over here. In case of Na plus, this is the nucleus. We have one and two shells. So it means whenever the nuclear charge increases, the size of an atom decreases. So here we have two things on which the atomic size depends. So first one is number of shells. As the number of shells increases, the atomic size will increase, and depending on the nuclear charge, so the nuclear charge increases, so the size of an atom will decrease. Now next we will talk about the trends in atomic size. Okay, so we'll talk about the trends. So first, when we are moving down a group, so down a group means hydrogen, lithium, sodium, potassium. So you can see electronic configuration of hydrogen is 2, 1, lithium is 2, 1, sodium is 2, 8, 1, potassium is 2, 8, 8, 1. So it means that the number of shells are increasing. So if the number of shells are increasing, that is the distance from the nucleus to the outermost shell will increase. Therefore, the atomic radius will increase. Okay. Now let's see if we move across the period. So if we are moving across the period, so let's see lithium, beryllium, boron, carbon, nitrogen and oxygen. So we'll write the electronic configuration 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. So here you can see that the electrons are increasing, right? The electrons are increasing the same shell. In the second shell, here we have 1 electron, here we have 2, 3, 4. So electrons are increasing, therefore the nuclear charge increases, which bring out the outermost shell, because of which if here we have 1 electron in the outermost shell. In beryllium, we have 2 electrons in the outermost shell. In oxygen, we have 6 electrons in the outermost shell. So because of which it is bringing the outermost shell near to the nucleus, and because of which the atomic size will decrease. In the same shell, the number of electrons are increasing, due to which the outermost shell will come close, and because of which the atomic size will decrease. I hope this is clear to you. Further, we'll continue in the next videos. Thank you.